Hello students, so we have started the topic application of derivatives, and today we will learn the subtopic maxima and minima. Okay, now in this subtopic we are going to find the maximum value of a function and minimum value. Okay, so suppose there is a graph, okay, like this. So obviously from the graph we can find this becomes its minimum value, right? And here it becomes its maximum value. Okay. Now suppose we take a example. Okay. So graphs we have seen in our 11th standard syllabus. Okay. So suppose I take an example, say fx equal to x square, and I have to find the maximum and the minimum value. X belongs to R. So we know the graph of this function, that is, if you take 0 here you will get 0, if you take 1 here you will get 1, okay, minus 1 you will get again 1, okay, for minus 1, for 1, then for 2 you will get 4, okay, and so on, okay, for all real values. Now the minimum value from graph you can find, that is this, right, 0. So f minimum will be for x equal to 0, it is 0, okay, and maximum value here can't define it, that is it becomes infinite, right? So maximum value is not finite. Okay, now same example, if it is given that x belongs to some interval, okay, x belongs to some interval, say -1 to 1, okay. So for fx, that is x equal to -1, you will get the graph here, right? Also for this, right? So here it is 1, so it will be f minimum will be same, that is for 0 it is 0, but f maximum now it is defined for -1 and 1, it is same, so f maximum are 2, okay. If I take here say 2, then it will be 4, right? So f maximum will be at 2 minus 2, it will be 4, okay. So this way you can find maxima and minima of a given function by drawing the graph. Now suppose in this we take this as a open interval, okay, these points are not included, so we are not including these points, so you don't know the value of x here, right? Because this will be something some 0 point around 2, it will be 1 point some 0099 and all that thing, right? So that number we can't define, so you will have f minimum is there, that is 0, right? But f maximum we can't define, so there is no real maximum, okay. So for this function, and also if you take other functions, say mod of x, you will get the graph like this, right? So f minimum is there, but maximum, if it is for all x belonging to R, you can't define, okay. If it is given in the interval, if it is closed, then you can define, okay. If it is not closed, it is open interval, then you can't define, okay. This is all about maxima and minima through graphical representation, okay. And second thing we are going to learn is to find local maximum, okay, and absolute maximum. I'm just going through the theory, okay. local maxima or minima and absolute maxima and minima. Okay, so if you have a graph, say like this, okay, now you know which are the points of maximum and minimum in this entire. Suppose this is the highest one. Okay, so this becomes your maximum, right? And suppose there is a very, so this becomes your minimum. Now if you take the entire interval, then you will get the absolute maxima and minima. Okay, so this is when you are taking entire interval, the whole interval. Okay, and if you are considering some interval, say a comma b, like this, okay, and in this f maximum you are finding, then this becomes your local maxima or minima. Okay, so this is when you are considering some local interval. Okay, so this is the difference between absolute and local. Okay, so let's now start with examples. Here you have to find the maxima and minima. This function is given. Okay, so we'll find it by using the interval method. Okay, so sin x, we know that sine of any function varies from 1 to -1, right? So I'm going to add 5 to this. 1 plus 5. So this is going to be 4 plus 5, and this will be 6. So its maxima, f maximum, is 6 and f minimum value is 4. So it lies between 6 and 4. Okay, let's solve this. So you have to find the maximum or minimum value. Okay, so we know that any square quantity is always greater than 0, right? So you can write here 2x minus 1 square is greater than or equal to 0. Okay, now I'm going to add 3 to this. So this will be 3. Okay, so for every x belonging to R it is given. Okay, so I have to find the minimum value. How to find minimum value now? This will have a minimum value if this term becomes 0. Okay, so if I take 2x minus 1 equal to 0, okay, then I'll get the value of x. Okay, now put this x in fx. So now check fx, f of half so this is 3. Okay, so this becomes your minimum value, that is f minimum. And maximum value, since there is only one value, that is this is for minimum value, you don't have a maximum value. Okay, so only one value exists, that is f minimum. So this is a problem from exercise. Okay, exercise 6.5. Second one also have a 9x square plus 12x plus 2. So you have to write it in terms of a plus b the whole square. Okay, so this will be, this is 3, right? So your a is 3. So 12 you can write 2 into 3 into 2. Okay, this is a, so this becomes b. So you need here 4, that is 2 square. So this 2 is already there, so you are adding 2 and subtracting 2. Okay, so this will be 3x plus 2 the whole square minus 2. Now this term is your greater than or equal to 0, right? Then you have to add minus 2 to both the sides. Okay, so this term will have a minimum value only if 3x plus 2 is equal to 0. Then you will get the x value. Okay, that is minus 2 by 3. Then you have to put it in the f, so you will get minus 2. So that becomes your minimum value and maximum value does not exist. Okay, now look at this question. Now this term x minus 1 the whole square is going to be a positive term, right? So it has a negative term, negative sign. So this is going to subtract, that is we are going to subtract something from 10. So this term, this whole term is going to be obviously less than or equal to 10, right? Okay, so whenever you will get x minus 1 equal to 0, okay, then you will going to get the maximum value, okay, that is 10. So you have to find x, which is 1. Okay, so at x, f at 1, you are going to get 10, which is your maximum value. Okay, so minimum value doesn't exist. Okay, let's solve this. So you know that a value of mod function is always greater than 0, right? That is positive, greater than or equal to 0. So you can write x plus 2 mod is greater than or equal to 0. Now subtract 1 both the sides. Okay, so you will get this. So this is greater than or equal to minus 1. So it's minimum value. Okay, minimum value we are going to get when this term is going to be 0. So x plus 2 mod is 0. So x you are going to get is minus 2. So for f of minus 2, you are going to get this value, that is minus 1. Okay, and this becomes your, this is, since this is greater than or equal to minus 1, this is your minimum value. Below it you are not going to get any value. Okay, and maximum value doesn't exist. Okay, now to find local maxima or local minima, okay, there are two tests, that is first derivative test and there is a second derivative test. In first derivative test you have to take the first derivative, okay, and then put the critical points, the points which you get x1 x2, okay, that you have to put in the fx and you have to see the values, okay, maxima and minima. For second derivative test you have to find first derivative, then put equal to 0, and then you have to find the second derivative, and in that you have to put the critical points, the points which you get, okay, and then you have to see whether it is greater than 0 or less than 0. Okay, so we'll just go through the examples. Let's solve this using first derivative test. Okay, so you have to first find the f dash of x, 3x square minus 3, then you have to put it equal to 0. Okay, so 3x square minus 1 is equal to 0. So from this you will get x either positive 1 or a negative 1. Okay, so you have 2 points, okay, at which f dash of x becomes 0. Okay, now you have to examine these points, means you have to take the right hand side or the left hand side. So here 1 is here, okay, so you have to examine the sign of f dash, okay, for these points to the right and to the left. Okay, so if I take f dash, this will be x minus 1, x plus 1, right? So if I put here 1.2, so this will be a positive into 0.8 plus 1, so this will be also positive, right? So f dash of x is greater than 0. Okay. Yeah. Okay, you have to put 1.2 both the sides. 1.2 minus 1, this will be positive and this will be also positive. If I put 0.8 here, so this is a smaller number, minus 1, right? So this will be negative, this will be positive, so the outcome will be negative. So f dash of x is negative to the left side. So this will be like this. Function is going to be, this is less and this is more, this is increasing, right? So it will be point of, for f1 it will be a minimum point. Okay, this will be a minimum. So you have to find f of 1. Okay, it is in between, right? So this will be f of 1 you have to find, that is 1 cube minus 3 1 plus 3, so this will be 1, so 1. So this is your minimum value. Okay, and then you have to do same thing for the minus 1. So if you take minus 1 here, so minus 1.2 minus 0.8. okay, so this will be minus 0.8 and minus 1.2. okay, then you have to check. So for minus 1.2, if I take here, this will be a negative, minus this will be also a negative, so this is going to be a positive value. Okay, and for this, if I take here minus 0.8, this is going to be negative, this is positive, so this is going to be negative, okay. So here also the function is, here function is increasing and here function is decreasing. Okay, so f of increasing and decreasing, so from highest point to lowest it is coming, so it is, this becomes your maximum. Okay, f of minus 1, then you have to put here, so minus 1 plus 3 plus 3 minus 1, so this will be 6 minus 1, that is 5. So maximum value is 5. Okay.